In this video, I'm going to talk about ionic equations, but just a small part of ionic equations, specifically the state of matter of the ions when we dissociate them. So for example, when we write ionic equations, we are looking for aqueous compounds. So in a chemical reaction, we might see sodium chloride aqueous written, or maybe aluminum sulfate aqueous, or maybe aqueous hydrochloric acid. So when we see aqueous, that means that the ions have dissociated. So for sodium chloride, you do not have sodium chloride. Sodium chloride is a solid ionic compound. If it weren't dissolved in water, it would be written like this. This is a solid. It's an ionic compound. It doesn't dissociate because it's not dissolved in anything. But if it's written aqueous, then we don't actually have any sodium chloride salt around. The ions dissociate. So what we really have is a sodium ion. This has to be aqueous. And we have chloride ion. This has to be aqueous. Sometimes students make the mistake and they want to label this as solid because it's a metal, and they want to label this as a gas because chlorine is a gas at room temperature. But that's not correct. The only way we were able to write it as ions is simply because it's aqueous. So it's still in solution. I mean, remember, this means in solution. It wouldn't be possible for this to be a solid because then it would no longer be in solution. So for the aluminum sulfate, you would have to write the aluminum ion, aqueous, and the sulfate ion. Have to include the charges. Aqueous. The hydrochloric acid, H+, and that's going to be aqueous, and the chloride ion, also aqueous. So when we are writing ionic equations and we break apart our aqueous solutions, they are written as ions with charges, and they have to be written as aqueous.